And we're live.
Great. Welcome back to Elasmo Week, everybody. I'm your host, Dr. David Schiffman. This week, you've seen some wonderful talks from scientists from all over the world talking about all sorts of really cool aspects of shark skate and ray science. And we've gathered some of them all together here for a panel, do a live question and answer session. So if you're watching this now, you can type your question in the YouTube video that you're watching, or tweet it at Elasmo Week, or tweet it at me at Why Sharks Matter. Some of our questions are for all of the speakers and anyone who wants to speak. Some are for specific people, but I guess let's start with everyone just saying something that you've learned this week. I, for one, enjoyed this and learned a lot, even though I've worked closely with many of you in the past and have followed your careers. What's something cool that you learned from paying attention to the talks this week, those of you who've been able to watch along live?
I'm always so happy when I get to see a baby sawfish. So thank you for that, Jasmine.
I was gonna say, I really hope I can be a science communicator like Jada is someday.
Thank you. I was going to say also, I loved seeing the footage of that saw shark being born and being like kind of pulled out of its mother. I thought that was one of the coolest things I've ever seen. So again, Jasmine, thank you for that.
Yeah, I always wondered how they were born with like the saw nose, and mystery solved. So I've always wondered, how is that done safely? You know, it seems terrifying, but I got to see like firsthand that they're like saw teeth. They're not quite out there yet. So it was really cool.
Evolution finds a way, man.
Anybody else on this one?
Well,
I have to say, go ahead, Francisco.
Oh, thank you. No, I just want to say that it was really great to get to know people that you know from papers, and it's always great to see their faces, right? And also to know that there's so many people that I actually didn't know before, and they're doing so much cool research that I didn't even imagine, and it's really great how wide was the spectrum in here. That was great. That was the best thing, I guess, in a week of shark science, right?
Annabella, do you have something? Yeah, please.
Yeah, I have to say that I really enjoyed Jasmine explaining how you can actually go from CT scan data to like the whole animal, and just like showing like the different steps, and doing that like with a little video was really helpful, because I don't think we see the backstage of what's happening in science frequently enough.
Awesome.
I was going to say, I really loved that ending there to Catherine's talk, where she's mentioning the rhetoric and like what's helpful when we're talking about inspiring people, and what are the concrete things we can look at doing moving ahead. So that was great.
I think my favorite part of Elasmo Week was finding out that my mother was watching Elasmo Week. So shout out to my mom, because she's definitely watching this. And I talked to her after Dean's talk, and she said, wow, who knew there were so many sharks down there? I thought it was just like nothing happening down there. So that was really exciting to know that my mother is watching, and she's learning about sharks, which is cool.
Awesome. Okay, another question for everyone. We're getting a lot of questions from undergraduate or high school or even middle school students about sort of career advice, career trajectory. How'd you get where you are? What advice do you have for someone who wants to pursue this sort of job? So whoever wants to tackle it, Jada, please.
Yeah, I was going to say my biggest advice would be to talk to professors and teachers. Like if you're an undergrad, definitely go to office hours, even if like you don't need help on a specific topic. Like just go to office hours, talk to your professors, see if they know anybody, have any connections that maybe can help you out. Definitely just talk to people and get to know people and make those connections, because networking is everything in this field. So yeah, just get to know people. I think it's really, really helpful.
And I can say, to build off of that, I started my undergrad research career by going to office hours. And I did it also by taking advantage of opportunities that came my way. So I didn't start out in shark science. I started out studying plants and insects. Those are my first papers. And what I was able to do is say yes to opportunities that came my way. And those are the opportunities that started shaping me as a scientist, that made me really competitive when I was applying for graduate programs and trying to really direct where I wanted to go with my career. I had this amazing background already. It wasn't in sharks, but I was able to, convince people that I was already building my scientific career. So say yes to opportunities, and don't think you need to spend huge gobs of money going to Australia, or, not to pick on Australia, it's an amazing place. But, if you're in the United States, it can be quite expensive. And during a global pandemic, it can be difficult. So don't think you need to spend gobs of money going all over the world right now. Take advantage of some of the opportunities that you have near you.
I also think something I often tell my students is to think of a question, like think of questions that interest you. So I was always like, I want to be a shark scientist. And I ended up doing it, but I think that's a little bit of a roundabout way to get where you want to go. I think it would have been much more helpful if I'd come in and said, I'm interested in this aspect of sharks rather than a specific organism or species.
Kind of jumping off of both of those, a lot of the techniques that you can apply to any fish or any animal, you also apply to sharks. So if you're interested in a question and there's no shark opportunities at this moment or where you are, you can still get experience within that field. And then once you have experience and you're a little bit more competitive and you have the resources to move around, then you can kind of find your way to what you were originally had in mind, or you may change along the way, and that's okay.
I would say start from who you are and build out rather than imagining where you want to go, which I promise isn't something you have a very good picture of what it's like anyway. So what are you good at? What do you love doing? What kinds of assignments, when you get them in class, are you like, score, I love this? And which are you like, nah? And go from there to if this is what I care about, what contributions can I make? How can I help? I think it's kind of common to get the advice that a PhD or an MS in shark science is the only way to be somebody who is concerned about sharks. But a lot of the people that I know that work with sharks, even on a daily basis, don't have advanced degrees, right? I work really closely with fishers and boat captains and all kinds of people who make decisions on a day-to-day basis that affect sharks and shark well-being. So what are the things you're good at? What are the things that you love? And how does that meet these animals that you're passionate about? Don't think about what you're trying to do as fit yourself into a box that we are describing to you. Think about your task as building a U-shaped box. What is your unique contribution to the problems that we're all working together to solve?
And I'll add that I think something that's really important, especially for younger people, is that all the adults in your life aren't necessarily right. So if someone tells you, oh, you won't get into that school, or oh, you won't be able to do this because you're not good at math, or oh, you won't be able to do that, just kind of ignore those people. Just because they're an adult doesn't mean that they're right. And when I was a kid, I had a lot of adults in my life tell me that I wasn't going to be able to do things that I've clearly done. So just because they're an adult doesn't mean that they're right. And just because you're a kid doesn't mean that you can't contribute and that you're not a person that is capable of doing science even right now. So you can start being a scientist right now. A scientist is just someone who asks questions and tries to figure out the answers. And so you can start right now, and don't ever let anyone make you feel small or make you feel like you can't do it.
Yes, I'd second that and say be really aware of the naysayers, and just don't take it personally. They're probably just insecure about themselves and about others, and they just don't know where you can go. But if you feel that you can do it, you can do it. You're just surrounded by people that believe in you. I mean, that's all we can ask for.
Yeah, and I'll add that you shouldn't feel like you have to have it figured out right now. Like, you don't have to know what you want to do right now. You don't have to know exactly what you want to work on or what questions right now. I am going into my PhD right now, and I don't necessarily have a specific project in mind, but I'm working on it. Like, you have people that are going to be there to help you think of projects and ideas and come up with cool questions that you can answer. Like, you don't have to have everything figured out right now, especially if you're like in middle school. Like, you have loads of time. So yeah, don't freak out if you don't have everything figured out right now. Just keep trucking along, and you'll figure it out.
I would also add to that, just, even though you're building on what everybody else has done before you, don't limit yourself just to what you see. There's so much more out there and what you're capable of. Do the best that you can do, not necessarily just better than what the last person before you did. Just go for it.
Also, does any single one of us feel like we have it all figured out? You're good.
Yeah, anyone who does at this point who says that they have everything figured out, I don't trust them.
Exactly.
Okay, and building off of this question, related to this question, several of our speakers who come from historically underrepresented minority groups in the sciences mentioned something along the lines of, when you were getting started as a student, there was no one you could look to and say, this person comes from my background and is a successful scientist. And that's starting to change thanks to wonderful, amazing scientists like y'all. But there are people saying that that's still sort of the case to some degree. And they wonder if you have any tips for what to do about that, if you feel discouraged by that.
Honestly, what I kind of did is I just kind of, like, this sounds so dumb, but I looked up to myself, and I was proud of myself. And I was like, oh, I'm making these moves. I'm doing really awesome things, because I don't even think I grew up with a Black teacher at all. Like, I think I had 2 people of color that were my teachers growing up. And that's all I had. And looking at, documentaries and stuff, I didn't really see a lot of women, especially women of color. So I didn't really have anyone that I could be like, oh yeah, I want to be like that person. I you know what I mean? It was kind of hard not having a role model that looked exactly like me. So you can kind of be your own role model. And I feel like people think that sounds a little conceited or self-involved, but if there's not anyone else out there, just be proud of yourself and make the moves that you need to make to get to where you want to go, and it'll happen. Because if you want it bad enough, you're going to make it happen. So be proud of yourself that you can make it happen.
I would like to say something.
No,
sorry.
Go ahead.
Oh, sorry. No, I just want to say that me as someone from South America is, most of the time we think we cannot do as cool things as you guys do in the North, right? In the North Hemisphere or in other developed countries. When you come from a developing country, like myself, sometimes you think you cannot do those cool things. But in my case, I would say that no matter what, so even if you work if you have the ocean, you have all you need pretty much. All I have done so far, which is maybe not that much, but still, all I have done so far is been without funding. For example, I was working with Fisher's garbage. Basically, I was picking up things from the beach. I was when they were discarding some skates and eggs, whatever, they just throwing those things in the sand in the beach, and I was there to catch them. So skates that were barely alive, I could put them in an aquarium and then keep them alive, and then have them laying eggs, and all what follows to that. So you just have to, basically, you have to want it. If you want to do things, you will figure out how to do it, and there will always be someone or some institution that will support you at some point. You just need a little bit of space, you need a little bit of water, and maybe then you can start doing things, and that will grow up naturally later.
Jasmine?
Yeah, I was just going to say that, kind of building off of what Jada said, not only being your own role model, but also wanting to be the role model for somebody else. I know that a lot of what drives me is that I want it to be easier for the people that come behind me. And so saying like, oh, I feel like I don't have role models, I want to be that role model for somebody else, really drives me. It drives all of my science communication. It drives all of my outreach. It drove us to fund Miss. And just saying like, okay, I don't have anyone. I'm going to blaze this trail, and the trail is going to be clear for everyone behind me. And that's going to be my contribution to the world. And that can be a big driving force, is thinking about lifting your community up with you.
Awesome. Anybody else?
I will say also one of the biggest things is I've like all my academic career, I've been in two heavily Hispanic areas, Miami and Texas, South Texas. And both times I've been the only Latina, like in a lot of groups. So it's been pretty othering, but also just seek out the people that are there, even if they don't have the same life experiences or ethnic or backgrounds. Find people that are your allies, because they're really going to help you. And that way it's not, the onus isn't on you by yourself to represent all this diversity. You can have people that are backing you up as well.
Catherine.
This is, I just want to make sure that you guys hear it from us too, that like, it's not that it's easy, and it's not that you can do it if you just want it bad enough, because I've been in the position where I've almost quit. I've been in the position where it's felt impossible. And I don't think that you need to feel bad if you decide you're not willing to go through it, is one last thing that I want to make sure that you've heard. It's okay to decide that what's right for you is not pouring yourself into shark science for the rest of your life, which doesn't mean we don't want you, because we definitely do. But it's okay to make whatever choice feels right to you. And you're not letting anybody down if you do that.
Okay, great. A completely different subject now. Now for something completely different. How has the pandemic and being not able to go to work the way we normally would affected your year? How has it affected your planning for the next few years? Is there anything that people can be doing to help you? Whoever wants to tackle that one.
I can jump in. So I'm with the Irish Basking Shark Group, and this is my first summer in the last 4 years that I'm not in Ireland, which not only makes research really, really hard, but also makes the outreach that we do really hard. So what we've been doing basically is relying on the public. We've been doing a lot of like SciComm online, and asking people to submit their sightings data, and starting to like build species distribution models, or models that tell us where the sharks are historically, just kind of trying to work with any data that's just laying around. So no new data being collected, but we're relying on the public really heavily right now.
Yeah, in my lab, we have a lot of video data. So we are analyzing that. My students are analyzing that from their homes. We start every meeting by checking in on our health and wellness goals, just because there's a lot going on and it is very difficult to manage professionally and emotionally and health-wise, right? But for me, my biggest, I guess, all the directions my mind is scattered, I hope that this year I can help my students make progress towards what they're doing. So I've kind of just made most of my goals about trying to get my students to where they need to go, because, you know, I don't know, my career's not stagnant or anything, but I'm like kind of I'm on a train and I'm going. But I really want to make sure that my students start to have momentum behind them as well. And so I'm putting a lot of time and effort into my PhD students, my master's students, and my undergraduate students and high school students working in my lab to try to get them the experiences that they all wanted to have, right? Because this really messed up a lot of what they were doing, and it's their early career training that is going to help them become the scientists they need to be. So I'm really trying hard to facilitate that as much as I can. And then one of the benefits to all of this is we have been doing so much more virtual work. So I have been able to give talks to tiny little kids, to everyone on YouTube, to a bunch of scientists all over the country. And so I've been able to really easily pop into Zoom and say hi to people all over and talk about my research. So it's challenging, and I'm focusing on my students, but there are some benefits, like being able to see all of you.
I will say the pandemic has made it like, pre-pandemic, you would try to talk to someone in another country and they would be like, I don't know when I can schedule. I don't really like to video chat. And now everyone's over their like awkward, no video chatting fear. And it's made collaborating with people in other places 1,000 times easier, because everyone now is just like, whatever, I'll get on Zoom. Do you like Skype better? Like, I'm no longer afraid of talking on a computer. I'm no longer afraid of like avoiding video chat at all costs. Like, I'll speak at weird hours. Like, nobody cares anymore. And that's actually been like really, I think, refreshing, and has kind of like made it way less stressful to reach out to people to be like, hey, can we talk about something for a minute? Like, I know we don't really know each other, but like now people are so much more open to just having a conversation in a really relaxed way, in a way that they weren't previously.
Yeah, and I sorry, do you want to go?
No, go ahead.
Okay. I just wanted to add, I think that this year I feel like I haven't been incredibly productive, and I feel like it needs to be said that that's okay, because this is crazy for so many people, and it's really hard on a lot of people for a lot of different reasons. So if you're not the most productive human being this year, that's fine. Like, no one should get mad at you for that, and you shouldn't be mad at yourself for that, because like you're trying your best during a really hard time under terrible circumstances. So just do what you can, like I have been, and you will be fine. Like, it's not, no one should be mad at you for that, because this is really difficult for a lot of people.
Yeah.
Juliana, then Jenny.
Yeah, I like the do what you can idea. I think that keeps me going a lot of days, definitely. And in relation to the pandemic and the lack of movement of people around the world, there's a really cool project going with the International Biologging Society that I'm sure a lot of people have heard of, but it's exciting to think about for a few months when there was a lack of human movement, when we think about like boats or just traveling in areas around the world, that affected the animal movements and animal behaviors as well. So in places like Sydney Harbor, where there's a ton of boats, coming in and out, and we're looking at shark activity there versus a few hours south where there's really not a lot of movement, and then even less movement now that this is happening. There's this whole international scale project going on with hundreds of different species looking at exactly what this pandemic has done to animal movement. So that's really exciting too.
Yeah, so I just wanted to kind of chime in on the opposite of that effect that is happening during the pandemic on the public aquariums, in that when everything shut down, we all kept going to work. All of the aquarists are continuing to care for the animals every day on split schedules. All the volunteers went home. Everyone's trying to take care of everything with far fewer staff. Some of the staff, depending on what the different risk factors were for certain people, were separating themselves out. Or, if people were falling sick, the teams get, lessened even further. And the load just has been very heavy on the public aquariums, as well as the zoos. And I just want to shout out to all of those aquarists and keepers who have been keeping the welfare level of all of their animals at the highest level through this whole thing, through the closures, the stress that's going on with your families, everything that we see on the news. But caring for the animals, like the back of David's screen of, his background is my old neighborhood. That's my old tank. So, this is why we do this. But the aquarists are for sure tired. Just as you imagine, like a lot of the healthcare workers, they've been doing 10, 11-hour shifts, split shifts, using half the staff, 0 volunteers. And it's, just whatever thanks that we can give to them, to the public aquariums that we work for. We do not want to lose these resources where people can go and interact with these live animals and see what their habitats look like in the middle of a city where you would not naturally find, these creatures. They are huge resources. And right now, as a lot of these facilities are opening back up, I encourage people to go and visit them, because they're putting into place the spacing to keep people safe. And it's honestly the best visit you're ever going to get, because it's like you're in there all by yourself for a private tour. It's awesome. And for the facilities that have not opened yet or are just starting to open, please go support your neighborhood zoo or aquarium. They need your help. We are, those of us who have been in this field, we are seeing our mentors falling off the map because of where some of these facilities are business-wise, because of the closures and all of the financial impacts. And it's, I'm trying to keep it together. We're seeing some of these pioneers that have come ahead of us going away, and it's really kind of terrifying. But the staff are all really hopeful, and we continue to take care of the animals. The animals are doing great, so please come and see them. But it's been a very, very busy, very full boat for us.
Great. So again, another completely different subject here. A lot of your talks, this question specifically references those from Marianne and Juliana, but anyone's free to answer this. A lot of your research involves some pretty cutting edge technology, tools that might not have been available or affordable even a few years ago. How does a new technology coming onto the scene like that change how ecology or behavior or biomechanics research happens? Are you in the middle of a long-term project and suddenly you see, oh my God, I can do this so much easier with this brand new tool? Or is it more medium-term planning? Or what happens when a new technology that can make your life easier comes onto the scene?
Juliana? No.
Yeah, go ahead.
Yeah, so a lot of the really great things that are going on in my lab are spurred by my grad students who have seen the things that I've done before, and they're like, I can do that better. So that's how some of the new technology we're able to kind of develop in the lab is working. And then other technology like our use of CT scans, that involves being able to have collaborators who have resources. And so a lot of times when you do need to use some of this cutting edge technology and some of these things that are really expensive, it's good to have your network of people that you can collaborate and work with to use some of these larger pieces of equipment. And then for the things we've been developing in my lab, it's a lot of trial and error. And, we've had like drones fly off and never return, so trial and error in a lot of ways, but it's fun. It's how we move things forward. And it's always good to have a good balance of science that you feel is really going to work and things that are going to fail spectacularly, because those are really great learning experiences. And it's the times that I have done something where I look back down, I'm like, that was really dumb. Of course, that was never going to work. Are things that I actually learned a lot from and was able to take the next step. So it's all about being creative and failing an awful lot.
I second that. I second the failing an awful lot. It's changed. I mean, the biologging and accelerometer tags have really changed everything for me. And, I haven't been on the scene as long as others, but this technology was something that I had heard about, and I was like, okay, this is so exciting. You're basically able to observe all the time, like 24/7, when in the past I'd have to be sitting there in front of an aquarium window, you know, taking those observations. And then that was still super exciting for me because it was the chance to see them all the time. But this way you could tag and track and automate everything in captivity as well as in the wild too. And the thing I guess I learned from the tech is that I think I was viewing it as kind of a silver bullet in the beginning, and I was very optimistic about it. And then, you know, as we're wading through this and we're learning more and more, I'm learning that, you know, this is not a, you know, fix all end all solution at all, because you need to ground truth that data. You have to make sure that that data is telling you exactly what's happening in real life, and that your models are sound, and that you're getting the right kind of, you're seeing the right things coming through in the accelerometry data. So as super exciting as it is and everything, I think I'm more cautious now moving forward, and just in making sure that what I'm seeing is actually what's happening out there.
Okay.
I would
Yeah,
second
sorry.
that. Go ahead, Alex.
Oh no, I was just going to switch direction as a really good example of how tech has kind of changed our understanding of sharks. We have a really prominent example in the basking shark literature, actually. So the sharks are often seen when they're like along coastlines. And previously, people used to think they were hibernating offshore, otherwise, like in the winter when they weren't around. And that actually wasn't until the 90s and then the 2000s with the development of the satellite tag that we actually learned they were doing these like global migrations when we weren't seeing them. So that's another really good example. But I do second what Juliana said about making sure that you're ground truthing everything. So you just have to be in the field as well.
I also wanted to add that sometimes, just like Marianne said, it's actually the students that actually will bring up the technology. They'll say like, oh, can we try this? Can we try that? And if it's coming from them, it also means like more energy and more like, you know, there's more time to develop to an idea. So for example, we were reading a paper about electrosedation, and it's not very feasible for like saltwater species, but we also worked with some freshwater species, and the students wanted to try it. It's like, well, you know, if we can like, you can figure everything out and we have the equipment around, so why don't you try? And then we'll clear with IACUC just to make sure that like the protocol is safe for the animals, and then we can certainly try it. But the students are actually, the younger people are actually the ones moving the field forward, and we are having to troubleshoot more. And normally like a new technology means more time. It's not like, it's not going to be easier just because there's a new technology. It just like takes more time. The learning curve is normally what's stopping us from doing it. But once it is implemented, and for example, just with the accelerometers, like I've used them, and I've used them in live fish, but then I was just like, well, but the video is so much easier to actually just like, it might take more time, might be time consuming, but it's like easier to troubleshoot. And so sometimes you have to have a trade-off between like when you want your data, what's the timeline. And the same thing goes for coding. So of course, we're trying to incorporate coding and automatized tracking in our labs all the time. But again, we need to train it, we need to check it, and then you also need to implement it. And the implementation sometimes takes longer than if you were to do it the hard way. So shout out to the students that actually keep us on our toes and keep us the field moving forward. Mm-hmm.
Yeah, I gotta give a shout out to like the increase in computer processing power, because I don't actually work with live animals. The basking sharks I work with are little individuals in an individual based model. So they're just little like computer animated sharks basically. And you know, 5 years ago, like there's no way I could have run that on my computer and gotten any kind of data. And now we're in a pandemic, and I can still sit at home on the couch with my cat and like type up a code and actually run something that gives me usable data. Not right now because my model doesn't work, but eventually, right? You got to keep checking that code again and again and again and again. Got to keep retesting it, but eventually it'll work, and I'll actually be able to run it and get data that's usable, that can be compared to real world data, and I never had to leave my house at all. And that's like astounding when I think about where computers were, you know, just like 10 years ago.
Great. Now we have a specific question for Jasmine, referencing the segment of the video with the baby sawfish and your sawfish fieldwork. What kind of needle do you use to draw blood from an animal that big with that thick skin, and where do you get it?
You use a big needle is the answer to that question. So we have various size needles. So like for hammerheads, we use like really long, scary, thick looking needles. And yeah, it's basically you just gotta, kind of similar to what the veterinarians use. You know, you've got to get specific needles for animals, and thankfully there's a lot of people that have gone before me that have done blood work and have tested all these needles and figured out what works. And so I just know, okay, great, this is the size needle, the gauge that I need to be able to get into the animal. And so yeah, I would say that I'm very thankful to everyone that has come before me that has tried to draw blood from all of these animals and figured out that like nurse sharks have super thick skin, and hammerheads, there you have to go really, really deep to be able to get it. All of that stuff is like very useful information that someone had to figure out. And so basically now at this point in our lab, we know exactly what needles to get and exactly what needles we need for every type of animal. And you can't use the same needle for every kind of animal. So it's not like humans where it's like, all right, we're just all the same pretty much, gonna use the same needle. Yeah, for every species of shark, it's a different positioning where you have to go in to get the blood, the length of the needle, the gauge of the needle, all of that stuff varies. So you have to know that ahead of time, or you're going to be doing a lot of poking and hoping things work.
And Jenny, did you have something to add to that? I know that husbandry is involved in a lot of, there's a lot of needlework involved.
Yeah, so I was going to say, not necessarily with the sawfish, but similar concepts, but with some of the sharks, we'll actually use spinal needles, which are, you know, fairly long, but they also have a stylet, which is basically has a rod inside the tube of the needle. So when you do the injection and it bores through and makes that little hole, you can pull the stylet and it keeps that bore empty. Otherwise, the other option that you have is to insert the needle, which then ends up doing a little bit of a core, because then it'll be plugged and you can't get anything through it. So then you remove that and then you thread a new needle back through the same channel, and you can tap into the blood source there. Also, there are various places where you can draw blood on sharks. They have different sinuses in different places. You can hit veins in different places, and we find that actually the blood values will read differently depending on where you're pulling from, and then the different kinds of anticoagulants that you use depending on what species you're doing will be different. So we are actually, the husbandry community is right now working on a blood chemistry database where we are lining up what species are you working with, where are you drawing it, what is the, what are the storage that you're using, what is the instrumentation that you're using to run the analysis, and lining up all of those factors that people then can actually compare blood samples to blood samples, because it's different from one species to the next, even within the same genus. So
that is super useful information, and I'm glad people that have stable work environments can go through all of that, because us in the field, there's no way we'd be able to figure all of that out. We're just trying to get it in and get the fish back in the water.
It's incredible. There's a colleague of mine. She's been doing lab stuff for the last 20 some odd years, and this is kind of the culmination of her career, and she is heading up this project, and this is going to be changing. This is going to be huge. So,
yeah, a great example of the ways that captive animals can contribute to field research and lab research. Awesome. A question for Jada. When you and Annabelle were compiling your list of the weird and wonderful species that y'all were ranking, what was the most bizarre or your favorite fact that you learned about any of these species that you didn't know before?
My favorite fact. Ooh, that's hard. I mean, my favorite fact, of course, is that bonnetheads are the only known omnivorous shark species. I did know that before, but it's still really cool, and I am obsessed with that fact. But I did not know that blue sharks can have 100 or more babies at one time, and they do give live birth. So that's all just babies stuffed into one little shark. So I knew that whale sharks can have like hundreds, tons of them. It's a ridiculous amount that doesn't even make sense. But they're such large animals. Blue sharks aren't nearly as big as a whale shark. What is as big as a whale shark, honestly? So it was so wild to me that such a guess normal sized shark fits so many other sharks inside it. Like that was crazy to me. So I think that was probably one of my favorite facts.
Awesome. Question here that whoever knows the answer, if any of us, can feel free to jump in. Are all sharks that give live birth born with umbilical scars like lemon sharks are? And I'm pretty sure the answer to that is no, but I don't know what the difference is. I see some enthusiastic head shaking if any of you want to jump in.
There is viviparity, which is placental, and then it used to be called ovoviviparous, but I think it's now called aplacental viviparity in sharks. So since they don't have a placenta, they don't have that like umbilical scar. So that is what I know. Did I cover that well? Does anybody else have notes on that?
Yep. Awesome. A question just coming in from the Twitters. What's something that you wish you knew, that you know now that you wish you knew right when you were getting started in your career?
I know Jasmine said this the other day when we were asked this question. She said she wishes she had known about shark burn, where you are helping with a workup on a shark, and then you stand up after wearing shorts, sitting on top of the shark, and you realize, oh, I'm bleeding now. So glad I have not experienced that yet, and now I have the knowledge to make sure that I try to avoid that. But that's something that was discussed before.
Yeah, yoga pants can save lives there. Some sort of field pants situation.
I have gotten shark burn, so I totally agree with that. Mine, on a slightly different note, is that just because someone is famous in the field does not mean that they're the best person to work with for you. And so I think we often get into labs because we're excited about working with a person. So I would recommend that people just look to work with a person who's a good fit for them, who's going to be a good mentor and ally and advocate. Whether or not their name is the most prominent in the field is like the last thing to worry about.
Something similar to that. Sorry, Catherine. Something similar to that. I wish that I would have, I guess I like conceptually knew this, but I didn't actually process it. I wish I had known that scientists are people, which sounds ridiculous, but I remember going to my first conference and being like terrified. Had like the worst case of imposter syndrome. I was an undergraduate student. My mentor was supposed to come, but he wasn't able to come. I was like, oh my God, you can't send me off alone. I don't know what I'm doing. I don't know who these people are. And I was like, they're going to talk to me. They're going to try and talk to me, and they're going to throw out science, and I'm not going to know what I'm talking about. And everyone's going to know that I'm a fraud and I don't actually know what I'm doing. And then I think the very first person that came over and talked to me was like, I like your shoes. And we started talking about shoes. And I was like, right, you are a human. You are a normal human, and you are capable of having normal human conversations. And you're not just sitting there judging me on all of the science that I know, because that's weird. And people don't do that, even at conferences. So I wish that was something that I knew, because I think that would have made it a lot easier for me to approach my professors and people in the field if I had realized that sooner.
Two that I learned the hard way through extensive testing. The first is that you cannot make someone a good boss or mentor by being a good subordinate or student. Like, it's not possible. There's no commitment you can show, effort you can put in, anything that's going to make them good if they're not. And secondarily, but relatedly, if you have teachers or mentors who are unkind to you, that reflects on them, not on you. 100%. They're telling you that they're a jerk. There's nothing that a student who works under me could do that would mean that I would yell at them or call them dumb. Like literally not one single thing. And you're talking to somebody who's been stabbed in the hand by a student with a tagging tool more than one time. That kid does not deserve to be shouted at. They're learning. It's a high stress environment. So like how people treat you reflects on them. They're not telling you something about yourself. So don't hear it that way. There's a lot of people who work out their own feelings on other people, but don't let that shape the way that you see yourself as a scientist.
I also want to say that standardized testing is not a good measure of how intelligent you are. Just because you don't do well on a standardized test does not mean that you're dumb. That's not how that works. I am not good at timed tests. Half the time I don't finish them, so I end up with a low score, but that doesn't mean that I don't know what I'm doing or I'm not a good scientist. And same with your GPA. Sometimes people just aren't as good at school as other people are, but that doesn't mean that they're less intelligent. So if your GPA isn't incredible and your test scores aren't above average, that doesn't mean that you are not good enough. It just means that you are, it's just not a good way of telling your intelligence. So don't let your GPA or test scores make you feel dumb, because they're not, that does not mean that you're dumb. That's what I have. Yeah.
Say as someone with really low test scores and GPA, always, you can still be a good scientist. And the thing that I wish I learned still, there's this thing called Imposter Syndrome where you never feel like you're good enough. And it is something that freaks me out still regularly. And I spend so much time and effort worrying about if I'm good enough or if other people think I'm dumb. And it's so much time and effort that I could actually be having those deep thoughts that are more useful to me, or just having fun, like for crying out loud. But it is something that is real. And I wish that, you know, I don't even know how to practice this, but just being confident and knowing you are a student. You're not supposed to know everything and be perfect at anything at any point in your career, right? We can, at any point in our careers, even the most senior people are still learning things, because that's how science works. And so we need to be lifelong learners. And if I could be confident that I am a good scientist and I will figure stuff out, and I will definitely probably not do well on that test, because that is historically how it goes for me. But, that doesn't mean anything about how I do my science. But just being able to somehow ignore imposter syndrome. If anyone has a great remedy for that, tweet me, let me know. But that's one thing that I definitely spent a lot of time thinking about, even still, because I haven't gotten over it. But you're a student, you should be learning the whole time. And I'm a student and I learn every day. So we should never be perfect and right all the time.
I was going to say, I think that a wonderful remedy for imposter syndrome is find yourself a hype man. I am a fantastic hype man for my friends. And they're like, I don't know, like my talk wasn't even that good. And I will grab you by the shoulders and be like, you're a scientist and you did all this work and you only did it in this many weeks. Look how amazing that is. You found significant results. You know how cool that is? And then my friends are like, wow, oh my gosh, you're right. I'm a scientist. I'm like, that's what I'm saying. You just got to find yourself a hype man who's going to tell you the truth and be like, look, man, you're incredible for so many reasons and you deserve to be here. Don't act like you're not supposed to be here, because you worked to get here. You deserve to be here. Like, you need a hype man.
Jada, I'm going to Google hype man after this, so I know what you're explaining to me.
Yeah, I love it. No, but if
I just say,
I'm
how the
my
Basking
hype man.
Shark group was formed was to have hype men. Like, we literally have a group text. We just hype each other up and talk about basking sharks. That's literally all we do. That's why
get yourself a group chat. Like
A
a
good
group chat.
full of hype men. If you need a hype man, tweet me. I will hype you up. I got you.
Okay, Jenny and Juliana, either order.
I don't know. I forgot what I was
Oh.
going to say.
Okay.
And I love this. I love the feeling of like, you know, just that's all we want to do for each other as well. We all just want to like throw back the ladder to each other and to others who want to come into the field and like pull each other up, you know, like whoever's here, whoever wants to get here, like that's what we're basically all about. And you can feel it in this whole chat, you know, like we're going to help other people. Like we're going to help other people get to where, you know, we've gotten and to get further and, you know, anything like that. So, I mean, all of these pieces of advice about, you know, removing these blockades that other people set up and the ones that we set up for ourselves are so important, you know. And to me, like, I guess the thing that I wish I knew was the you can learn anything, you can do anything, like despite you know, difficulties with math or statistics or anything like that. It's just a matter of you can do it, and removing those blockades for myself is what I had to do. And yeah, having a hype group and multiple hype people is definitely a recipe for success.
I remembered what I was going to say.
Awesome.
And it was,
and then Francisco.
yes, it was when you are looking for a place, either a lab or a job or whatever it is, as you're going forward in your career, think about fit. Think about fit with people, because those are people you're going to be spending a lot of time with, and sometimes more time than with your family, unfortunately. But think about that, because even if you have the coolest job in the world and the people that you work with are miserable, that's not going to be awesome. So really think about that. Also think about that, you know, when you're doing your interviews, when you're really excited about doing something and joining an organization because you've heard about all of this stuff, like really the interview is two-way. It's not just please take me. It's you take some time to think about what's important to you and decide like what are your deal breakers, and then go in there and, you know, and ask questions, because at some point they're going to be telling you all about it, and then they're going to be like, do you have any questions for us? Have some questions that are meaningful to you, and then evaluate, does what their answer, you know, does that match with how I want to be, how I want to go forward, how I like to conduct myself and want to be treated, and all of those things. But definitely it's not just you trying to get somewhere, it's you trying to get to the place where you are going to be happy and thriving.
And sorry, one more thing. Talk to the students that are in the lab that you want to be in, or the people, anyone that has worked with the person you might want to work with, because they will be honest with you. And you want to make sure that you get it from not just the advisor, but from people who are in the position that you're going to be in. You want to make sure you get it from all angles and make sure that you do your thorough research and make sure that person is right for you. Sorry.
And Francisco, did you have something? Please.
Okay, yes, I'll be brief. One of the things that I think is a usual mistake is also when you compare yourself, or when you try to reach some standard of somebody that is super cool and awesome, and you say, oh, I'm so far away from that. And just think that that person have been working in the field for 20 years maybe, and that whatever they achieve or know by the moment is a product of years and years and years of effort. So don't pretend to get there like in 2 weeks or when you're starting, right? So it's always, I don't think it's very good to compare yourselves to others, because that may lead you to frustration. And if you don't have the self-confidence that some people have, I mean, that may have a really negative impact in your career, and especially if you're starting. So my advice for that would be just try to plan ahead for several years, like for make short-term plans and just achieve little goals, and suddenly you will be really high and you will realize it later. So don't pressure yourself and don't kill yourself pressuring with some unachievable goals.
Can I say something super fast?
Sure.
Something else that I really wish I had known when I started getting, because I kind of wandered into shark science. It wasn't something I set out to do from the beginning, but there is room in the field for people from all backgrounds, from people with all different passions. And it's not just people who want to be hands-on with sharks on the field all the time. There is so much we still don't know that we need people from all different backgrounds for. So there is room for different people of different scientific and educational backgrounds for.
Yeah, building off of that, when I was an undergrad, I got a bio degree, and I used to worry that I wasn't sciencey enough because I would leave my bio classes and read history books and sociology books, and then would have to like study really hard to like memorize, the parts of the cell and stuff. And now that I'm getting a PhD in environmental science and policy, all of that history and all of that sociology is really helpful for conservation and for policy and for understanding, especially like fishery science and stuff. So having that separate interest that I thought made me like a lesser scientist actually became like a really serious benefit as I went on with my career. So like definitely embrace your interests and like don't worry if you're not sciencey enough, or if you have like these obscure interests that you want to pursue on the side. Like a lot of those come back and are like give you skills that are really helpful.
Great. Well, we are just about out of time here. So wherever you are watching virtually, we can't see you, but I know you'll join me in giving all of our speakers this week a round of applause. I hope you learned a lot. I hope you found some great new folks to follow on social media to fill your feed with all sorts of sciencey and geeky goodness. And hopefully we'll see you again next year and see you around the internet. Thanks very much for watching, everybody. And thanks to all our speakers for your time. Bye.